Awesome. Thanks, Annie. Yeah, so we have two tutorials planned that are going to run in parallel. So there will be two breakout rooms, which you can join either on your own. And I'm going to have the tutorial leads introduce their tutorials in just a second here. As a little bit of background, during the ESIP summer meeting that was in Pittsburgh last summer 2022, we had a very successful sort of working session where people broke up into groups. I particularly was in the tutorial session for Kerchunk, and it was a really great way for people to start to sort of work on code themselves and start to come up with their own questions. So I think the tutorial leads have some great materials, but I definitely think that part of the point of this session is for you guys to, as attendees, to all like try something new out that's particularly interesting to you and actually get some hands-on experience. So I just want to say that like really the point here is based off of the success in the past of people actually getting their hands dirty with trying some things out for the first time or repeating something that they've tried in the past. I think that's all I wanted to say about that. We are going to come back here with 15 minutes left remaining in this time block. So with the last like 10 minutes, I want everybody to share out something that they learned. So everybody, when we return back to the main room with 10 minutes, I think if anybody who's willing to share something that they learned or something that they want to try out again on their own in their own time, we're going to have some space to do that at the very end as sort of a wrap up. And yeah, I think that's all. So yeah, with that, I'm going to pass it to Matthias to talk about to introduce his tutorial, and then Julia. So maybe just like a minute pitch for your tutorial, and then we'll create the breakout rooms.
Thank you, Amy. Yeah, so Benjamin and I will be talking about Openio and Openio platform. Those of you who have not attended the lightning talks earlier today, Openio is basically a common language to like make geoprocessing available in the cloud. For example, you could then share workflows across Google Earth Engine, Planetary Computer, and like Openio platform, for example. And we'll dig into that today. So first of all, give an introduction into Openio, what it is, how you work with it, then give a demo based on Google Earth Engine, basically in a more visual interface where you don't need to code actually. And then go over to Openio platform, which is another implementation of Openio in the end. And there Benjamin will give you an introduction into how you can make use of it and how to run data processing on it. It's not as much getting hands dirty today because as the issue is with cloud processing platforms, you first need to register and then, well, you can use it later on. So we will provide you with information how you can actually register and make use of it later after the meeting. Yeah.
Sounds good. Cool. Julia?
Yeah, so this is going to be an intro to Dask tutorial. So it's going to be covering the foundations of how Dask works, as well as the high-level collections that you may have encountered before. So it'll be talking, so Dask, I guess to zoom out a step, Dask is an open source Python library for distributed and parallelized computing. So we'll be talking about Dask data frame, which is for data frame workflows similar to Pandas, Dask array. We'll be focusing more on Dask array for n-dimensional data analysis. And we'll be talking about how that relates to Xarray and how Dask actually backs Xarray. And then we'll be talking a little bit about distributed and how to deploy to different types of clusters, and about like more functional approach that allows you to use Dask on functions rather than on data directly.
Awesome. Cool. So with that, Annie, did you want me to create the breakout rooms or did you have them already set up?
The rooms are already set up and they are open. So did you see them pop up for you, Amy?
Yeah, I see unassigned. Yeah, so we can all, if you go to click the breakout rooms in your Zoom interface, I see now OpenEO and Dask. So we
Yep,
can-
just scroll down to the bottom and you'll see the 2 room options.
Cool. All right. So yeah, does anybody have questions? I'm gonna probably join one of the rooms, but I want to make sure everybody's in there.
No, where do we see the rooms?
If
Somehow.
you click the breakout rooms in the, for me, it's at the bottom of my Zoom interface.
Okay.
Cool.
Oh, okay.
And Amy, I will hang out here. It looks like let me see who's joined what, but
Actually, it looks like we have a pretty even distribution, which is
it
great.
does. I know that's what I was thinking. I was like, wow, way to go,
Really?
everyone.
Really worried
Or,
that one was gonna be.
I know. We had that one time where like 3 people were with one and there was like 50 in another. So yeah, this worked out well.
Wait, this is amazing. It's 15 and 14 right now.
That is crazy. All right. It looks like Jake, a community fellow, is in OpenEO and Dask has Mike. So Sudhir, were you still having problems joining?
Yeah. No, I'll just make it even 15 on the.
Okay.
And looks like we've still got Chan and Jenny here. Right now we have 2 breakouts happening, one on the OpenEO platform and another on Dask. These are both kind of hands-on tutorials. So if you'd like, you can go to the breakout room button and scroll to the bottom and join either of those rooms where the tutorials are being led.
Thank you.
You bet.
Welcome everybody, and good afternoon to the US, to the OpenEO platform tutorial. My name is Benjamin. I'm gonna start out the meeting with actually a little questionnaire that we have prepared. I shared a link in the chat. We are just asking you, or if you want to join via the phone, we're just asking you to answer these 3 very simple questions to actually get a bit to know you, and what we would expect from you, like your previous knowledge and so on. There's no private questions or anything in there, so no private information or anything like that. It's just about your previous knowledge of Earth observation packages that you have been using. It takes about 2 minutes to answer, and I'm already seeing the first answers coming in, so that's very good. Thank you. This is just for us basically to steer the training a little bit into a direction that we know what you know the most, and how we can use that later on. So perfect. We are almost at 10 answers. I give it another, let's say 20, 30 seconds, then
Can you maybe drop the link in the chat again? I'm having trouble with my Zoom and I keep dropping in and out.
no worries. Here we go.
Okay, thank you.
You were faster, Matthias. So we are at 14 answers. I think that is a quite good representation. What we can see here, most of you know Python coding already. That's very good. We are going to look into Jupyter notebooks later. 7 of you actually also know Jupyter notebooks. GIS systems like QGIS, ArcGIS, GraphGIS, and so on are on the next level. That's also good. And only one person actually knows OpenEO or OpenEO platform. That's what we are actually looking. And which technologies are you familiar? So as expected, since you're used to Python coding, you are also used to using Xarray, Dask, Shapely, and so on and so forth to do your analysis, and vector and raster data are also very common. So we can speed up things actually here, since you are pretty knowledgeable in data cubes and so on. Yeah, most of you want to get to know OpenEO. That's that's quite obvious, but also like how compliant those platforms are and examples of workflows. We will dive into that for sure. And with that, if there are no further questions, thank you for answering that quick questionnaire. And I give the word actually to Matthias, who will show you what OpenEO by itself is. And later on, we are going to come back to my presentation, and I show you what OpenEO platform actually is about.
Thank you, Benjamin. Now I'm unmuted, I hope. And you should see the screen as well.
It's perfect. Thank you, Matthias.
Great. All right. So yes, this is the first part, which is focusing on OpenEO, and Benjamin is going to talk about OpenEO platform. As this gets confused quite often, quick introduction of what the difference is. OpenEO is basically the standard or the specification, let's say, and the ecosystem around the specification. And OpenEO platform is a implementation of that specification. So something like if you implement an OGC API, then the OGC API is a specification, that would be OpenEO. And if you have an implementation yourself, which, I don't know, serves water boundaries as features, then that's your implementation of the OGC API. So that's basically the equivalent of OpenEO platform. What we're going to talk about today, well, the poll we've already done. So we'll talk about why do we need OpenEO, then give an introduction into OpenEO. The demo will be followed afterwards. This will run on Google Earth Engine using the Visual Web Editor. And then in part 2, Benjamin will talk about OpenEO platform. So why do we need OpenEO? Well, first of all, you probably know all that we have quite a number of EO data processing platforms out there. We have Google Earth Engine, we have Microsoft Planetary Computer, we have, well, like all the European implementations, such as the Vito Terrascope backend, and so on and so on. And all these things use very different, or used very different APIs. So if you want to process data on Google Earth Engine because they have the corresponding data, and then you want to process something else and need to use Planetary Computer because they have the other data set, you need to learn 2 different languages in the end, and use different tools, etc., etc. That's really a barrier for entry, basically, of using these data sets. So the idea is basically, let's make a specification that combines this all and gets rid of this, where you have all the different languages and ecosystems around in R, Python, JavaScript, that all need to talk to these individual backend implementations and make them, accessible the same way, basically. This needs a bit of work, of course, especially as they are all different. And we don't really want to make it in a way that they are forced to change their existing interface and use OpenEO. But you can, like most of these implementations are basically a proxy on top of the existing implementations and just are a thin translating service basically into the native language that these platforms are using. Then the other issue, of course, is that, and we've seen that just on Monday in a podcast, basically, where Planetary Computer, Google Earth, and QGIS were compared. Basically, they had specialists for all these different platforms on the podcast, and were all doing flood mapping on them. And then they tried to run the same thing. They had all different code. The results looked all the same because they were all doing also different, slightly different algorithms in the end. And that was not comparable. The only thing they in the end compared were the numbers of the pixels that were flooded, but you couldn't really compare the individual results. And that's also something that OpenEO wants to get into. And we did such tests at the beginning and on 6 different implementations. And we saw that some are actually very similar and some are different. And then we could, or we have looked into that and realized why that is. Sometimes it's a bit different pre-processing of the data. Sometimes it's just that a tiny bit of information in the data is different. For example, an offset is different, that for one, they are scaled from 0 to 1, the numbers, and for one, they are scaled from 0 to, I don't know, 10,000 or something like that. And then you get these differences. And that's something that you can then try to get over by implementing the same processes and the same API, basically. That doesn't solve the issue with the data sets are different, right? You still need the same input data at some point. But otherwise, you can basically get the same data out and compare between the backends. You can run the same code on the same on different backends, and then in the end compare the results. So how do we solve that? Well, first of all, between those clients and the backends, you need an API that you can communicate with. That is defined in an open API document, basically. That's very similar to the OGC APIs, basically what for example, OGC API processes does. Although processes, for example, is just specific to run like more high-level processes on something, and doesn't really describe how you like discover the data and how you visualize it. That's other OGC APIs that do that. You combine more into one API here so that you have a full blown solution in the end by mostly reusing OGC APIs. Again, not necessarily processes, but all the others. And that is defined. You can have a look at api.openeo.org if you're into APIs. And then one thing that is very, that's outstanding, basically, because no one else, I think, did that before, especially not, for example, the OGC API processes, is that we also define processes in the end that each backend can implement, so that in the end, you can run the same things on the backend. It's a bit like you have, for example, like the API is a grammar of a language, and then that's what OGC API process offers you. You still need to define the individual processes, and everyone does it a bit differently. OpenEO also defines the processes, so basically something like a dictionary. Basically, that the actual language works in the end, and you can understand that everyone can understand each other. So the implementation is there then for R, Python, JavaScript. They all have the API layer in between and can access the different backends. And that is very lightweight. Now, at the beginning, we thought that that's a central instance, basically, that you connect to, and then that connects to the individual backends. So you would have a massive thing in between, like GDAL. But we did it more that now each backend has individual proxies there, and you connect directly to the backends. In this way, it's more decentralized. We use existing OGC API building blocks. Basically, also Stack is heavily part of OpenEO for data discovery, and also the data that you get out after processing is also Stack. So you can ingest that again into other Stack compliant tools or processing tools, platforms. The processing itself is a bit split into multiple parts. So you have 3 different processing modes in OpenEO, which is first of all, you can just send a processing algorithm to the backend and then wait for that, and you directly get the results back whenever they are processed. That is synchronous processing. Or if you are looking for larger extent processing, like planetary or continental scale, or even country scale, then you send that as a batch job. Basically, you just submit it, and then it gets queued. It runs. You can log out during that time. It still runs in the backend, and at some point it's finished, and then you can request the results again. The third one is on-demand processing via web services. So that, for example, if you go to WebMap and underlaying is an OpenEO service, it just computes on the fly the tiles that you're looking at the zoom level that you're looking at. So that's a bit faster, and we'll see that later. And part of the processing is basically to select the data, you make an algorithm via the OpenEO processes, basically send that to one of these processing modes that gets then executed at the backend. What you do locally is only generate this processing graph, so you don't process anything locally. You just generate a graph that is sent to the backend, then executed. And once it's done, you can download the results basically via any Stack compliant software. This is all centered around data cubes. So all the processes that we have are basically data cube processes. Data cubes itself are massive multidimensional arrays, usually with like 3 or 4 or 5 dimensions, depending on what data you have. EO data cubes, for example, usually have an X and Y coordinate, the spatial dimensions, temporal dimensions for each time step, one label, and then a bands dimension, or if you have other data that is not multispectral, then you have something else. But yeah, that is what it looks like. Usually you see a representation here at the right, for example, for a 4 band data cube with X and Y and 3 timestamps. Basically, that's just a visual representation, of course, because after 3-dimensional, you get stuck with your representations usually. Then it's not really a cube that we know. Anyway, data cubes in OpenEO are usually significantly bigger than your main memory of your computer. So that's something that you need to compute in the cloud, because otherwise locally your computer gets stuck. Yeah, and then you basically have a data cube that has dimensions. Each dimension has different labels. The labels itself, for example, are either the band names or the timestamps, so like the date and time, or for the spatial dimensions, it's the coordinates, basically. Yeah, and then the nice thing about data cubes is that it's basically pre-processed. You don't need to care about scenes, right? Not the individual captures. That's all already combined into a data cube. So you don't need to fiddle around with file formats or like how to merge these into mosaics, etc. That's all done for you up front. You can directly dive into the algorithm that you want to apply. Yeah, and in the end, you just process what you actually need. So because it's just giving you just what you requested, you just process over the area, and you don't need to like do more processing than what you actually want to look at. The OpenEO API itself, I will go relatively quickly over because it's relatively technical. But what you can do with the OpenEO API is basically, it gives you the basic functionality to connect to the API, it returns you or informs the client about what it is capable of, which file formats are supported. It gives you an overview over which data sets are available. It gives you a list of processes, and these are described in a way so that the clients can adopt to whatever is available. So each implementation can choose which processes are available. And for example, if you have something that you want to resample and one backend can do only nearest neighbor, you can see that directly, and others may do something else, and that is all something that you can see later in the client. Basically, we'll get into that as well later in the web editor. You can from these predefined processes, you can make new processes. Like for example, if the backend has implemented mathematical processes for minus, plus, divide, multiply, etc. From this, you could do a new process that is called normalized difference to like compute spectral indices, store that at the backend and reuse it. So that you not each time you need to do the mathematical formula, you just insert the individual bands and then it computes it. So that's like programming where you do new libraries and reuse them, right? That's the same behavior here. I've talked about the data processing, that you can do synchronous processing, you can do batch processing, and the on-demand processes via secondary web services like WMS, XYZ, WMTS, etc. Of course, you can upload your own files to the server so that you can like upload a GeoJSON file or any like auxiliary data that you have and want to use in your processing workflow. Authentication, of course, is required. And then there is also a concept in OpenYO that is called a UDF. We may know it from the database world, where you can run, like if the predefined processes that we have are not enough, you can run your individual Python or R code basically on the backend, so that if you're stuck with the predefined processes, you can go a bit further and use, for example, other libraries that you know and want to reuse. Some extensions have been defined for the API. There's an order extension, a federation extension. Federation means if you have multiple implementations, want to hide that behind a single entry point. That is what OpenYO platform does. Then you can inform the clients about that. And order is for requesting and managing data from long-term archives or commercial data. The predefined processes can be found under processes.openyo.org, and that's extensible. Everyone can submit there if they want, and then over the period of time that gets into the specification, basically. The main thing, of course, are the data cube processes, and then there are a lot of processes to handle one-dimensional arrays, do something domain-specific for climatology. There are logical operations, mathematical processes, etc. And all these can then be combined into a so-called process graph. You see an example here where you load from two different data sources, then rename labels, merge them together, and do some operations in the end, save it, and then you can run that on the backend. This, in the end, is what is created on the client side and then sent to the backend for execution. And this can be arbitrarily complex. Usually you start with working on the data cube, and then you dig deeper depending on the function that you execute or the process you execute. You can, for example, apply over all pixels, or you can reduce a dimension, which is, for example, done when if you're doing spectral indices, then you would go over the bands dimension, pick the individual bands that you're looking at, and then return a data cube that has no bands anymore, but the spectral indice values, basically. We have 3 different clients right now that can access OpenYO APIs, or let's say programming language libraries, and on top of that, there are more clients that can access the OpenYO API, of course. That is Python, JavaScript, and R. If there is anyone that wants to work in Julia or something else, that's of course also possible. Although it needs a bit of upfront work to implement such a client for the API. Here you see an example of such a workflow. And if you're looking a bit closer here, you see that we choose a collection, set a spatial and temporal extent, choose bands, and then run a couple of processes, ARD normalized radar backscatter, apply, save result, and send it to the backend. That's how a normal procedure could look like. That results in some imagery. And then for example, if you go to the R client, you could do basically the same. It just looks a bit different because the programming language is a bit different, but you see directly that the process is called load collection again. You can merge cubes, etc. It's all very similar. You can even transfer between multiple languages. So if you have code in Python, we have in the OpenIO web editor a way that you can basically transfer your R code into Python code, or JavaScript code into Python code, or R to Python, etc. Right? You can transfer between languages, so that also helps to make teams with different backgrounds in programming languages work better together, because they can work on the same problems regardless of what programming language they are used to. We have a JavaScript client that is, of course, mostly used for web applications, because most data scientists actually work in R or Python, I would say. JavaScript not so much, but either people coming from Google Earth Engine because they have no JavaScript, or they want to use or implement something for the web, they can use that client. We have implemented the OpenIO web editor, which we'll look into later, which is a visual interface for OpenIO. And then there are a couple of implementations right now for that implement the OpenIO API. This is just a list. For example, there is a proof concept for Google Earth Engine that's not maintained by Google itself, but by me basically. That's so it's a third-party project basically. So that's not full-fledged, but just gives an like view of how it could look like, and that it actually works. We will look into OpenIO platform later. Through that, you can also access SentinelLab, for example, and then there are GrassGIS implementation from Mundialis, the Swedish Research Institute implements it, Vito on top of their Terrascope backend, Urok EODC, which Benjamin is part of, and EODC, for example, uses the Dask X-Array stack, and Kleos are implementations of that. And we hope that this grows over time so that you could, for example, also set up this on the planetary computer in the future. So now I'm going into the demo. Although maybe, how do we go with questions? Should we do that now before the demo or afterwards? Not 100% sure.
Probably a good time to pause in case somebody has questions.
Yeah. So if there are any questions, has anyone monitored the chat?
Nothing in the chat.
Questions, yeah, no questions so far.
Otherwise, just maybe speak up. It's probably the easiest way forward.
I think everybody is happy and you can go on, Matthias.
Or just overwhelmed, yeah. Now I'm trying to share the other screen. Let's see. That should work, right? You should see a very blue screen, right?
Perfect,
so
yes.
That is the OpenIO web editor. Let's see. Oh,
There is one question now from.
Yes.
Can you call from notebooks or need a special platform?
You probably mean Jupyter Notebooks, right? Yes, that is possible. The OpenIO Python client can be run in a Jupyter Notebook. It's actually very nicely integrated. Do you show that later, Benjamin?
Yes, actually, I will almost only work in a Jupyter Notebook, so all good.
Good, yeah, so that is possible. Also, it's nicely integrated. Our client is nicely integrated into our Studio and our Markdown. We have a set of very nice UI elements, basically, that are used in the web editor and also in the notebooks, etc. So that the return values from the API are not just pure JSON, but can be rendered in a nice way, in an HTML way, so that you can interact with them. We will see that later in Benjamin's talk. Any other question?
So far not.
Good, then I'll continue, and otherwise just interrupt me. So you can also call this right now. It's editor.openio.org. Maybe Benjamin, you can put a link in the chat. And then there are a couple of backends you can connect to. I'm just choosing right now the Earth Engine backend, which is this URL. And if you input that, you can connect to it, and then it asks you for credentials. The slides that are in the Google Drive have credentials, example credentials that you can use. It then connects to the Google Earth and backend via our OpenIO account, basically. So it's like not overly, like if 30 people work at once, it doesn't work very well because it's just going through one account. So there are some memory and CPU limitations. But that's just because it's a proof of concept, right? In long term, you would need to connect to your own authentication details for Google Earth Engine, and then it would work a bit better. Anyway, that's the details. You can then either click no credentials as well if you don't have credentials, and you can just use that to basically inspect what the backend offers. So it shows you then this interface where you can have a look at what is available. You can like open the list of Google Earth Engine collections, click on any of them, and then it gives you all the metadata that you need: a description, the spatial extent, temporal extent, the data cube dimensions basically that you work with, the bands, if there are any. Well, that just says one band, but anyway, that's how you can go through all these collections. In the end, you can have a look at the processes, right? That are the OpenIO processes in the end, not the Google Earth Engine processes. And it gives you descriptions about this process, how it works, what the parameters are, etc. It also shows you the file formats and other things that would be supported by the backend would be listed here, basically. So if there is UDF supported, then it would list them here as well. Yeah, so that's mostly for exploring. So if I now go and log in here with some random credentials, you will see a bit more of the possibilities, especially this area here, where you see the different processing modes, the data processing for batch jobs, synchronous processing, the list of batch jobs that have been started. You can do for each of them, you can do different things, edit them, show the processing graph again, edit it, delete, start it, edit to the queue, download the results, show logs, etc. Then there is also the interactive view for web service. So then it would show like tiles on a map, basically. This is a custom process mode, which I explained earlier, where you can like use processes and then make them into a larger processing, like define basically a new function and reuse it in other processes, basically, so that you don't need to reinvent the wheel all the time. And upload files here to the processing platform. The main thing here is that you probably want to do is to generate a processing graph, and that is done here in the upper part. And what you basically usually do is you just select a collection here, for example, Sentinel-2, drop it in, and then that's your data set that you want to load. Then you can go in, select like spatial extent, temporal interval for, I don't know, whatever time. Select the bands that you want to work with. And then that's configured. Then you can run any data cube processes. Like if you want to apply, I don't know, absolute value over all pixels, let's say, you can just drag and drop it in, connect the result to the next node. Then you go to the settings again and say, well, I want to compute the absolute value here. And if I can type, it also shows it correctly. Each value is then passed into the absolute function here, submitted, etc. You can do that for whatever you want, your use cases that can go arbitrarily complex. For this example, I just go into the wizard. That's a simplified mode for some use cases, because let's just compute a spectral index for whatever area. So I choose that use case, choose a data set that I want to work with, for example, Sentinel-2. And then it gives me a list of spectral indices, and then I can choose, for example, NDVI here. And now it automatically, from the metadata, detects which bands are applicable. So you don't need to choose the individual band names. Now we want to go into some kind of area here that we want to compute. Let's do something here. Select that bounding box. Now it asks us for temporal extent. Let's just use, I don't know, June of 2020. Start at the first, and then until the end of the month, for example. Well, that didn't work as expected, because the 31st in June doesn't exist, of course. Input that, then we can choose how we want to, like I explained before, we have X and Y as dimensions, the temporal dimension, and the bands dimension. The bands dimension is already getting removed by computing the spectral index. So that now we have 3 dimensions left. But to get an image that we can show on a map, we need just a plain 2-dimensional image, basically, that this can be shown on a map. Otherwise, we would have multiple layers on top of each other that could work, for example, for an animation. But if you just want to show a plain image, you need to still reduce the temporal dimension, all the values or all the captures that you have for the month that we've selected, into a single image. In this case, we can choose from a couple of different reducers here that reduce the temporal dimension. Let's, for example, choose a minimum value of all these individual time steps. Then now we need to choose a file format. I'm choosing PNG here because that works for web services. It automatically asks whether we should scale the values that from an index are -1 to 1. That doesn't work in PNG images. They always have 0 to 255. So it asks us whether we want to scale that to the corresponding range. Check that, and then we're done and can either submit it as batch job, synchronous processing, or as run it as web service. That's not possible right now, just because I didn't get to it yet to implement it. So we say don't execute right now. Now we have here the process graph generated, and we can have a quick look. It explains that we are loading the data here. It needs a near infrared band and the red band, that is B8 and B4, that will be loaded. Then the first step is to reduce the temporal dimension with a minimum, as we've selected. The next step is here then to compute the NDVI. We can have a look. That is the formula that it generated. It looks a bit weird because it's like all the different mathematical operations that apply. If that's a bit too complicated, you can just go into this mode, and then it shows the formula here, basically. And then it applies the scaling from -1 to 1 to 0 to 255 for the PNG image, saves the result as PNG. If we want to further work with that in Python or R, we can go to this button here that exports it into another programming language, and then it gives us the code in the individual libraries. So we could now copy this code into JavaScript environment, or use this Python code here to execute it, or the R code. That's the way to convert between the languages as well. You can import into this area here and then export again into another language. If you want to now have a look at this computing or this algorithm, basically, or the results, we can go into the Web Services tab here and click Show on Map. Then it submits it to the backend and starts computing. It loads the individual tiles from the Google Earth Engine backend and shows them on the map. You can zoom in, zoom out here as usual, and then it recomputes directly. And this all runs on Google Earth Engine right now, but you didn't even touch the Google Earth Engine libraries at all. You just used OpenEO for that. yeah, that's the demo from of the web editor, how it works, and how you can make use of that. Yeah, I think that's it from my side. If there are any questions, you can always ask them. Otherwise, I would hand over to Benjamin. But I see the first question here. That is good. So is this list, collection list curated? And when would new collections get added or updated? The collection list for Google Earth Engine itself is basically just the list that you get from Google. It only supports image collection images. That is the type of collections that you have in Google Earth Engine. There are also tabular data, which we don't import, but otherwise it's just the plain list of all the collections that Google Earth Engine has. For other backends, it's different. In OpenIO, in OpenIO platform, there is a different list of collections, of course, that has the main things like Sentinel-2 or Landsat or whatever. And then basically we add collections there as required, right, Benjamin? That is basically the way it goes.
Yeah, exactly. If a user wants to have a collection from us and it's free and openly available, similar to Google Earth Engine, then we would, yeah, exactly. Actually, Amy is just answering the question. So in the end, backends have their collections available. Some might be specific to the backend. Some might be specific to, free and open source available data. Yeah, that just depends on the backend, what is available.
Exactly. So for example, here, that's Google Earth Engine, and it has quite a number of collections, 923 right now. Very long list, but I can basically just show it right now. I can disconnect, for example, go to, let's say, where is openio.cloud? Let's open your platform, connect to it. That's a bit slower. And then without credentials, I can just connect and see what's available there. Here you see that it has 111 collections available, and that's basically the list of collections that is available on OpenIO platform right now. Right, it's a different list, and that is pretty much curated by the backend in the end. And for when it gets updated, like that's also pretty different. For example, Google Earth Engine is always synchronized whenever I restart the Google Earth Engine driver, basically. And for the others, well, it's on demand, basically. Yeah, that's it from my side. Any other questions?
No,
I guess
I can't.
I'll ask a silly question. So that collection could also just be a public stack catalog, right?
In principle, we have the functionality for that in the specification. But as far as I know, please correct me if I'm wrong, Benjamin, that is not really supported by any of the backends yet. I mean, we have
not yet. Yeah.
Yeah, not yet.
So,
I mean, it's planned. We have for example, functionality to load results, existing results that we've processed. That is also a stack, but right now we can only load those because we have control over how the metadata looks that we export. Loading random stack catalogs would still require a certain amount of metadata, basically, especially the DataCube metadata. And if that's not present, it's a bit more difficult. So that's still a work in progress, basically.
Thanks.
Ed has his arm up.
Yeah, Matthias, I had kind of a similar question as a previous question on Stack. So, I mean, you're working on supporting Stack, but I mean, if you have a repository, a curated collection, I think you went over this in your architecture diagram, so maybe kind of rehash, what are the kind of the specifications and protocols for a curated collection to allow it to play here in the OpenEO? So is it just the OGC specifications and OpenAI, or is there more to the sauce, so to speak?
Yeah, so that what I've talked about is basically how the API exposes the offering, basically. So that is for the data sets is Stack. if you want to visualize something, for example, what we've seen from Google Earth is a Sleepy map tile XYZ. Could also be, we have other, like the Veto backend implements WMTS for visualization. That is what is exposed through the API to the user. What the backend does internally is really up to the implementation itself. The data doesn't necessarily need to live there as stack metadata. For example, I'm pretty sure that the Veto implementation uses either stack metadata or has a open search catalog in the backend that is also queried. And that's different for each of the implementation, right? For example, Google Earth Engine, although they have a stack catalog, internally they store the data completely different. I'm not even sure how they store it. So that's completely hidden, and it's up to the implementation in the end to decide what they do. The only thing is that they need to expose the collection metadata for each of the collections through the API, not necessarily even the individual items that they have, because OpenEO is primarily for processing, not necessarily only for data access. So not all the implementations necessarily have a downloading part where they can just go with a stack implementation like PyStack and just download random data. That is possible, but not required, basically.
Okay, thank you. Thank you.
All right. I think we have like 20 minutes left. So I will quickly go over OpenEO platform and show you basically a bit of Jupyter Lab. Matthias, do you want to stop sharing so I can?
Sure. I thought you can just take over. But,
I wasn't going to take away the screen from you. So anyway, that was the Microsoft Forms. So what is OpenEO platform? In the end, it is an implementation of OpenEO on a federated infrastructure. So you can run, similarly to what Matthias was just showing on Google Earth Engine, your Earth observation analysis on our infrastructure. Why do we really need this? Basically, I just wanted to describe the data management burden here that you probably are all aware of. So you log into your your infrastructure, like, I don't know, like your common VM infrastructure at your university or so. Then you identify your data and you have to pre-process it, resample it spatially. And then at around step 7, when you apply your algorithms, you realize, oh, sorry, my network storage is full. So you need to go again and request from your provider, so from your VM provider, another bit of network storage to store your results. Well, in the end, OpenEO takes all this into account. First of all, Matthias has shown this pretty nicely in his lightning talk, but I'm just elaborating a bit on that. So you have the Google Cloud, you have the G users, you have the AWS users on Sentinel Hub, and then basically all these different implementations and users. And here you can see what OpenEO API really did, providing this common language so that you don't have to actually search for your cloud implementation anymore. You can just use the same language. So what does OpenEO platform do? In the end, we add another aggregation layer to this. So basically in between the backends and the client, there is an aggregation layer. So what you as a client or you as a user do with your client, you just authenticate and identify with OpenEO platform. And in the end, this layer also hides from you a little bit, let's say, the processing. Technically, you could also split jobs between those backends. So currently, OpenEO platform runs on 3 backends. That's the EODC backend. We are Xarray and Dask, so Pangeo compliant. Terrascope is a GeoTrellis implementation, and that also runs on CreoDias. And right now we are currently, so this is actually should be updated. The Eurodata Cube and the Sentinel Hub is becoming a new backend right now. Exactly, the concepts of data cubes, I don't think I need to go massively into that, as Matthias has elaborated on that quite a bit. Basically, all our backends depend on this data cube structure, and all data in OpenEO platform is represented in this multidimensional arrays. So what has been done till now, you might ask? We have a quite active user community that actually implemented quite some use cases specifically for their research. So for instance, here we have, this is going to be published soon, I think, selective logging sites in the Central African Republic. So basically you get the ground range detected from Sentinel-1. You have your magnitude and the time basically of disturbance, and you can actually analyze how long it took for the logging site to actually recover from the logging. That was done on OpenEO platform at the beginning of 2022, around till mid 2022. So this was also presented at the Living Planet Symposium. The other use case from the community, I'm just going to go quickly over that, was basically a river discharge analysis, where the person or the researcher analyzed these river benches and how they actually correspond to the river discharge itself. And that was done all over the planet, actually. And you could see that the OpenEO cloud data really, or the Sentinel-2 data in that sense, really corresponds to the local measurements of the river discharge for those rivers. I want to really stress that we have also quite an active user community. All our developers are also in this forum. So go and take a look at the forum. Maybe Matthias can post the link to the forum. I have it on the slides later as well. And you can just log in with any social account. So in general, we use for authentication the European Grid Infrastructure technology from EGI. So EGI stands for European Grid Infrastructure. So there is a single sign-on that you can use with your Google account, with your GitHub account, and so on. So exactly, I have elaborated on that already. There are some documentations, and the forum is also available on forum.openeo.cloud. Are there now currently any questions? Maybe quickly, just a second.
None in the chat right now, at least.
Not in the chat. So how does it actually work? So what you do is you go to openeo.cloud. You end up on this website. There are a couple of general information on the top. The Get Access button. Currently, we provide a 30-day free trial. So you can register for that. There's no fee or anything included. It's completely free. And then we give you access for 30 days. And you can test the platform as you wish in those 30 days. If you have something bigger in mind, you already are sure, okay, this is the platform supports my kind of use case, then you can also apply to a network of resources sponsoring, even for non-ESA projects. I think, Matthias, you can answer these questions also in the chat. So the network of resources sponsoring is available up to 5,000 euros for any non-commercial project in the end. Yeah, what we want to do is we want to go ahead and log in. So what you can do is you can open up the Jupyter Lab. I will be logged in right away because I already have signed in this afternoon. But once you have registered, you basically get a Jupyter Lab login. You can also go through the editor. So basically, when I go here, then it directly connects me to the web editor. And here I can use the login button to log in. We will do that in a second, actually. So what I wanted to show you is what I wanted to show you is the Python representation of OpenEO in a Jupyter Lab notebook. So what you're doing here is, in the end, you import the OpenEO client. The package is called OpenEO. I'm just going to enlarge that a little bit for you. And then you can print out the client version. I'm using version 0.12.1. I think there are regular updates, so this might even not be the newest client version. And then I authenticate with the platform. So through my cookie that I have put in with that EGI single sign-on, I'm gonna use a refresh token. But when I ran it for the first time this afternoon, you saw that I have to put in a device token that my device is authenticated, I think, for 30 days. Exactly. And then similarly to what Matthias showed earlier in the web editor, I can just define a spatial extent, a temporal extent. I can define a collection. And I can define bands. And our intention here is actually to run a force processing workflow. So force is a package that lets you do analysis ready data creation in a different manner. There are, so with the Sentinel-2 level 2A collection, there are a couple of smaller issues, I would say, that force has solved. So if you want to apply, let's say, better, or like if you are after this force correction method for several reasons, then you can use that in OpenEO platform with the ARD surface reflectance process. So in the end, we're going to load the collection Sentinel-2 level 1C collection with all the bands. Then we are going to we are not fetching the metadata here, and we are going to apply to that data cube the surface reflection process, and then we are going to save the result in NetCDF. So I have now created that graph, the processing graph, and I can also use flat graph to actually show that. And what Matthias didn't show before is actually this is the raw representation of a processing graph that gets transferred to the backends. So in that sense, for OpenEO platform, the collection actually decides which backend this is sent to. In a minute, I will show you also the other representation again from that processing graph. Here you can just basically, on our connection, we create that job. That processing graph gets then passed to the OpenEO platform aggregator and gets passed on to the to the backend. This is actually going to run at the EODC backend. So here I can start the job now, and shortly after I can see, okay, this batch job is created with the respective identifier. And then I created a little function here to actually run through and tell me, okay, this job is running, or is it finished, or is it actually queued, or what is the status? So you remember that we were at the web editor, so I can actually log in with my EGI single sign-on here again. And in the end, yeah, here I'm already logged in. I get this little maybe I need to try again. Yeah, so perfect. Getting a little error, but here my batch jobs and the collections, as Matthias showed, are loaded. And what you should see in a second is that my current job that I sent away with the Jupyter Notebook is actually running. So I can get an info about that job. I can get that representation of what is happening. I can get all the metadata here from that from this processing graph, what is actually put into the force processing and so on, all adaptable and all pretty obvious. Exactly. So as Matthias stated, in the web editor, you can also do various adjustments to the processing. And since this processing is running for, let's say, 10 minutes or so, because I picked quite a big area of extent, 3 by 1 degree, we are going to go into a quick other demonstration, actually much faster, into the synchronous job. So this is now running on the back end, this job. This is a batch job, and we are waiting on the result. In the meantime, I'm going to show you what it means to run a synchronous job. Basically, synchronous job calls mean that you directly get an answer from the backend, because you actually know, hey, this area of interest or this data amount shouldn't take long to process, and you can actually directly get it from the backend back. So same story again. Here I'm just importing a couple other libraries alongside GeoPandas, Pandas, Shapely, and so on for the geometries. Our task here is actually to have a look at the NDVI values of various cereals, so maize or rapeseed and so on. And we are going to look at the NDVI signature of a potato field. So here I'm going to authenticate again. I don't know if I did it. No, I didn't. So here I authenticated again with my refresh token that has been stored in the back. And so here we are going to load a Sentinel-2 level 2A collection for 2 years with the bands that are only necessary for the NDVI calculation. And also we are directly going to mask for clouds in the calculation. So we are not taking clouds into account. So this creates once again our processing graph. And here we pick the crops to use. So we have like a little GeoJSON file in the back that then holds the geometries for different cereals. In our case, we are going to take this polygon here that looks like this, and we are going to use that polygon to pass now onto the backend. So we want to compute the indices of that Sentinel-2 masked, the NDVI indice here. And now here we are going to do a temporal aggregation over 10 days with the reducer mean. So basically, every 10 days, we are gonna have a data point in the end. And in between, please interpolate linearly between those data points. That's what we are telling the backend here. And then in the end, we are aggregating this spatially over the GeoJSON from that potato field geometry. And we are getting, we are getting back the time series. Exactly. So it's Q2. Unfortunately, we don't have 3 minutes. You just need to believe me in that sense. That we in the end can get the potato field and the standard deviation from that potato field as a synchronous call. It would run around 2-3 minutes on the Vito backend, and I think I'll leave it there. Nevertheless, I want to show you really quick on how to get access, or actually what we had planned to provide you is a trial access exclusively for all of you. The only thing what you need to do is you need to write an email to this email address, and we will provide you.
Sorry for the yank back, Amy. I had just
That's
closed
okay.
it before you said that.
Benjamin, maybe you could actually give that instruction to the whole group, then everybody could have it anyways.
Yeah, sure. So what I was just saying in the OpenEO platform breakout room is that you just would like to, if you would like a test account with low barriers, basically, you get a login and a password sent to you. You can just use this email address, write us an email basically saying, hey, from the ESIP training, we would like to have a test account for OpenEO platform, so I can answer to that email and provide you with that test account. So you have no hassle of registering or signing up an account, and you can still do that after your test, your trial period. Thank you.
Awesome, thank you so much. I just posted in the chat a link to a Slido poll. It's just an open-ended question and answer, question being what's one thing you learned in this session, as a way to add your, what you sort of, add your sort of, one takeaway from this session, as a way to sort of digest what you learned there. So please add something there, or if anybody's willing to go off mute and share what they got out of that past session. I just want to give a couple minutes for that. Maybe while people are thinking to themselves, Julia, and since I wasn't part of the other session, Julia and Jacob, how did it go?
Yeah, it went really great, I think.
Yeah, we made it through. A little tight on time with the new time constraint, but yeah, pretty good overall.
Okay.
Yeah, I think we'd taken material that was previously a 4-hour tutorial and like tried to trim it down to 90 minutes. So it was quite a pace, but hopefully it was good for everyone.
Yeah, I think we trimmed it to exactly 90 minutes rather than like 90 minutes with padding.
I'm sorry. I feel like I'm always iterating on this setup and configuration of these meetings. So thank you for being flexible. I am wondering if we want to continue it in another ESIP cloud computing. If you think there's enough interest, we could also continue it in another cloud computing cluster knowledge sharing session. I don't know. What do you guys think about that?
We made it through, but I think if people wanted to do more interactive stuff or do more exercises stuff, that might make more sense.
Yeah, cool.
Same for OpenEO platform, actually, I think, or for OpenEO in general. Yeah.
So I was in a Dask one, but I think I definitely think there was a lot, right? We didn't get the chance to actually really work on. work on it, it would be probably good to have even a desk a little bit larger, or maybe 2 blocks split into that, so that we can do section 1 and section 2 on that, at least to have, I mean, so that we have opportunity to actually, or users have opportunity to actually even try out some of those. And maybe, so I definitely see it will be really valuable to have these sessions extended and try it again.
Yeah, Rich, I was gonna ask the same question, actually, if there's ever a desk office hours. I think that would be a really cool thing to set up if it doesn't exist.
Yeah,
and-
we don't particularly have something like that. We have like a community meeting that's on the first Thursday of each month. You can find it on the like events page on the Dask website, which is kind of, it's scheduled for an hour. We maybe spend a bit of time on general community stuff, and then it's kind of open forum. So if folks have questions, that's a great place to come and ask questions.
Nice. I think, is
I'll
that
put a link in the chat.
Jim that has his hand raised?
Yeah, sure. So you asked if we learned anything. And what I got from the Dask session, that's where I was the low level stuff. You always hear about the pandas and Xarray stuff, and it's wonderful and it's cool and everything. But I was really interested in the futures, particularly because we use futures a lot in our Python code. And it would be, I see a potential that Dask could enable us to take what is right now our single machine Python code using futures to move it over to clusters of multiple machines. And I think that's something we could probably take advantage of in AWS. So that was really cool. And I really like the low level stuff.
Awesome. Yeah, well, I was excited to hear that OpenEO, that some of the things that we've been thinking about, like vector data, are on the roadmap. So that was cool to learn. Oh, cool. That's a great link too. Thanks, Jim. To the previous presentation on OpenEO ITNI. What's ITNI again?
I'll let Annie go for that one since I'm gonna butcher it, yeah.
Oh my gosh.
Information technology and
Information
interoperability.
technology. Thank you, Mike, for saving me.
Cool. Anybody else want to share something that they learned or excited to try?
I could also share some of the respondents on the poll, since I don't think you could see it. Unless, can you see the answers that other people gave?
I can't.
No, so I'll just have a couple. I learned about Dask Futures, live loading with Google Earth Engine on OpenEO is cool, exclamation point. How many components there are to the OpenEO effort? I think every one of these has an exclamation point. Exclamation. I learned about OpenEO. I love the idea and excited to see where it goes. EO data is very different from climate model data. Upside down smile face. People want to install OpenEO clients through Conda, and there are many ways to access and utilize the cloud data. That's probably a good thing at this point. Interesting and exciting.
Awesome. Okay. What was I gonna say? Oh, are there any other ESA sessions that people are planning on attending or presenting at the next couple of days that they want to plug? As we're sort of closing, I think this is the last session for today, so I'm not sure actually if there's anything after this.
There is the research showcase, and there's a lot of really good content there, and a great way to have lots of conversations hopping around from poster to poster. So I would really encourage folks to stop by the research showcase, and you can find the link in Kiko chat and pop back and forth between the different posters. So I would just encourage that.
Cool. Yeah, well, I really wanted to thank our tutorial leads this time around. I think it's always hard to do these virtual sessions and lead tutorials to them. So definitely open to trying new things in the future to get this to work, because I think it's a format that people really enjoy when it's successful. So I appreciate you all trying this out for me and coming and coming with us on this journey. So yeah, definitely look forward to continuing to talk about OpenEO and Dask, either in the ESIP Cloud Computing Cluster, or it looks like the Dask has a community meeting. I don't know if OpenEO has any community venues.
Yes, we have every first Wednesday of the month at, well, probably very early in the morning. But if anyone is interested in joining, just write me an email, openeo.psc I'll just drop it in the chat and you can send me an email and I'll invite you.
Nice. And I didn't even get the chance to say also, like, for all the, all the you guys in Europe, thank you for doing this so late in the day for you. So, cool.
Thank you for organizing, Amy.
Yeah, thanks a lot. And
Thanks, guys.
the next big meeting for OpenEO is actually EGU in Vienna.
Cool.
Looking forward to it.
Awesome. Yeah. Well, I might be there, so I'll definitely look for it. All right. Thanks, everyone. Looking forward to seeing you all around. Bye.
Thank you. Bye-bye.
Thanks. Bye.